ئەم کاتتان باش کوڕینە چڵا من ئەم دەرسە وەکو پێشەکێک باسی ئەم کۆرسەتان بۆ بکەم کە چی بکەن و چۆن دەرسەکانە خوێنین لامان کاتە چی شتێک لەسەر ئێوە پێویستە و شێوازی سعیکردنوشت چۆنە بێت و چیمان هەیە ئێمە کە پێویستە کات لێرەیە لە لامان بێت. پێش هەموو شتێک is there anyone who cannot understand Kurdish? If not, I'm going to explain the whole lesson in English.
I can, sir.
Yeah, you can't. All right. Any more students? Only one?
I think there are 4 students.
4 students. Okay. In that case, I'm going to explain the whole thing in English. I'm going to explain everything in English. All right. Now, for this course, we have this booklet that I have prepared for you. And please, anyone who hasn't still taken this notebook or this booklet from school, please, after the lessons, you can go to school and grab one of these because we are going to study everything here from this booklet. And there's another one also. Be careful. We have a teacher's assessment booklet or book, which contains only questions. So grab that one too. So all you have to do now is that you have the booklet and that teacher's assessment question book as well. Now, my name is Rahel. I'm going to be teaching chemistry this course in the summer. We'll try to make it the most out of it. We'll try to make it very successful. I have prepared everything from your books inside this booklet. So you don't need anything from the book. Everything that is required, anything that is necessary to understand the subject or to solve a question, I have included it inside this booklet. So you don't need to go back to the book. What is included in this booklet? There are all the notes necessary from the book. I have also added some more notes that are also not in the book. All the practice questions, which are mostly required, section review questions and chapter review questions, so that you don't have to go back to the book every time you want to solve a chapter review question. And the section review and chapter review questions, I have added standard answer keys. Standard. So they are the correct answer keys. The calculation questions in chapter review and section review, we only have the answer key, not the solution, not the whole step. So when we try to study chemistry, all of this booklet is required on you, from the practice questions, from section review and chapter review, because every year, most of the questions are asked and sometimes without changing numbers even from the book. So you have to solve every single question. As a 12th grade teacher, I cannot solve every question for you. So be careful. You are responsible for solving most of the questions. It's not like 11th grade or 10th grade that I have to give you homework, I have to give you things to solve. No. In 12th grade, in the beginning of this course, when I tell you that you have to solve this, that you have to finish this, you are responsible for it and you have to evaluate yourself. The teachers cannot give you homework or stuff like that. Yes, I can guide you. I will tell you which subjects to study, what to do, but solving the questions is up to you, whether you are going to solve it or not. And this year's chemistry, everything is related to one another. What do I mean by this? Every chapter is related to the next chapter. So please try to focus, try to concentrate with me from the beginning. Please try to not to skip anything, not to skip class, not to skip any guideline that I give you, please. And besides just listening, you have to study. Because if you just listen and we finish chapter 1, you might forget chapter 1 if you don't study very well. And when we get to chapter 2, it's entirely related to chapter 1. Then you will suffer. you will have a lot of problems in chapter 2. Same thing for chapter 3 and 4. From 1 to 4, they are very related to each other. So you have to be very careful. In chapter 7, it's entirely related to chapter 1 to 4. See, that's how related they are. For example, chapter 5 and 6 also related. 8 and 9, 10 and 11, together they are related. So it's very important that you keep track what you are doing. So we're going to start from chapter 1 at first, and you have to come with me. And this year's chemistry is also related to last year's chemistry as well, or 10th grade as well. Don't worry about that. Even I know some part of 11th grade you have studied through online lessons, and some of them in school. I will try to explain or review all the subjects that we need from 11th grade so that you can understand the things in 12th grade. Because there are some things that you really have to know it in order to understand the subjects in 12th grade. So don't worry about it. Even if it's from 10th grade, I will review it for you. I will remind you which subject is related to it, and I will try to explain it very thoroughly. So that is for our relationship. And in any subject that we need 11th grade, I will try to explain it as well as possible. All right. Now, what you have to do, it's better, all the practices in this booklet, I have added a space for you to solve the questions. But for example, for chapter review questions, or even for section review, I have added some space. But for chapter review, since there are a lot of questions, you gotta have a notebook for yourself. Especially most of the questions that you have to solve it as calculations, you need a notebook. So it's better to have it. And if you solve all of them right now, it will be easier for you to study them during school time. Some difficulty will be lessened for you during the school time. So that was for chapter review as well. And after this booklet, I can say the required thing to do is that teacher's assessment that I told you, teacher's assessment question. That book contains questions from the original Holt book. The original Holt book actually includes the subjects from 10th grade, 11th grade, and 12th grade. But in our government, they have separated all those three into 3 years, and they have this book prepared, which is called the Teacher's Assessment, which is actually for teachers, not students. But since we are in a different situation, that we have ministry exam questions, that's why we give you those questions as well, so that you can solve them. That's also a required book, because many years, or like every year, at least a couple of questions are asked from that teacher's assessment, at least, sometimes more, exactly without any change, because it has been translated to Kurdish as well, and they ask questions from that book as well. So be careful what you are going to study. So now, what is required for you? The book, which is the booklet here, all the notes, all the questions from practice, section review, and chapter review, and the teacher's assessment questions. The teacher's assessment question, I'm not gonna tell you anything, what to do, what not to do, because it's required for you. It's your responsibility that you solve them. But I will try to tell you after each section which questions to solve. And of course, when you finish the chapter, during 1 week, please try to finish all the questions from that assessment questions, please, because it's going to be very important for you. It's going to be better for you to understand the subjects. If you do that, when you come back to the subjects and you study them, you know how to study because you have seen the questions. The most important part here in 12th grade is actually questions. You have to see as many questions as possible. As many questions as possible. Inshallah, we will give you another test bank during school time, which contains a lot of questions as well. which it's very important for you to solve them as those two. If you finish most of the questions in this summer course, your work, your job during the winter time will be a lot easier than if you haven't done anything during this summer. All right. Now, those were my notes to be successful in chemistry. Now, let's start a review from previous years. We'll start with matter. This is actually from 10th grade. Matter, if you remember the definition of matter, anything that has volume and mass. But we don't care about the definition. What is important here? It's classification. This map is a very good start for you to understand the later on subjects. You know where are you studying. For example, in 10th grade, you have only studied pure substance, mixture as definition, but you only studied elements. In 10th grade, you only studied elements. In 11th grade, you studied compounds. In 12th grade, homogeneous and heterogeneous mixture. We'll also add mixture. Until now, you haven't studied mixture in a detailed way. That's why this map is important for you. Let's start with matter. It can be classified into two parts, pure substance and mixtures. What is a pure substance? Pure substance is a substance which has its own properties and characteristics. For example, H2O, helium. For example, if you look at H2O, it has its own characteristic and properties. You can say H2O is liquid. You can say H2O is colorless, is tasteless, and so on. It has its own unique property. Same thing for helium, same thing for other substances. Then pure substances are formed or classified into also two parts, which are elements and compounds. What are elements? Elements is a single kind of atom. For example, like chlorine. What else? Let's say fluorine, bromine, oxygen, hydrogen.
Teacher,
Yes.
I see your screen.
ما صيان شاشة ما
شاشة نما هوا زين شاشة كسيو باش استبابا
that's good.
For example, like fluorine and oxygen or hydrogen, like that, those are also elements. They all have their own properties. They are actually a substance, all right? They exist. Also carbon, for example, from coal is also a substance, or iron, acid, iron, or gold, silver, and so on. We have all of these stuff which have their own properties, and they exist as a pure substance, and they only contain one type of atom. But if the substance contains two or more types of atoms, what do we call bonded atoms? Two or more types of atoms. We call them compounds. For example, CH4. It's composed of carbon and hydrogen, but they also have their own properties. They are substance, they have their own characteristics and their own properties. What do I mean by this? H2O, it's composed of hydrogen and oxygen, but hydrogen is gas. Oxygen is also gas. Oxygen is also gas. Oh. Oxygen is also gas, but H2O is actually liquid. So it has its own property. H2O is liquid. It doesn't have to have the same properties as the elements itself. Let's say C12, S22 O11. This is sugar, which is sucrose. If I ask each one of you, what is sucrose? What is sugar? Describe sugar. You will say it's a white powder, solid. It tastes sweet. But actually, it's composed. It has its own properties, but it's actually composed of carbon. While carbon is black, it's the color of charcoal. Hydrogen is gas, oxygen is gas, but together they become a new substance which has its own properties, its own characteristics. That's why it's called a pure substance. A pure substance. It's a substance that you can recognize it, distinguish it from another substance. All right? Now, let's, I don't know what's going on. Something weird is happening. All right. Now let's go to mixtures. Mixtures. Mixture can be divided into two forms. What is a mixture? A pure substance with another pure substance will make a mixture. Two or more pure substances will make a mixture. A mixture has two forms. It's either homogeneous or heterogeneous. What is a homogeneous? Homogeneous, if you look at any source, read any source talking about homogeneous mixture, it will tell you it has a uniform composition. What does the uniform composition mean? It means that if you have a container, we'll dissolve sugar inside that container. We dissolve sugar inside that container. And I take samples from this mixture. A sample here, a sample there, a sample there. If I test them in a laboratory, I can see all the samples are actually the same. They contain the same amount, the same percentage of a certain amount of material, the same thing, the same property, the same color, everything. For example, tap water. Tap water is not H2O. Be careful. Tap water is not only H2O. It's H2O with a lot of more minerals. For example, it contains other salts and other minerals and a lot of stuff. That's why tap water is a mixture. It's a homogeneous mixture. If I take samples from that water from three different places, the bottom, the middle, the top, I can see that they all have the same property, the same composition, the same thing, everything. That's what is called uniform composition. That's uniform composition. But heterogeneous mixture, let's say we put sand into water. Let's say the big particles of sand are in the bottom, have precipitated in the bottom, dropped into the bottom. And there are other small particles. The bigger particles are in the bottom. Some smaller particles on the top. Very small particles like a blurry thing are on top. If I take samples here, there, and there, I will get three different results. I will get three different composition, three different percentages, three different things. That's why we have to call a heterogeneous mixture as what? A non-uniform. It has a non-uniform composition. It's not uniform. In every place it's different. At every sample is different from the other one. If I take samples, that's what it's called as heterogeneous. All right. Now we clarified the classifications. Yes.
clinical جواه
Yeah.
نابینم بەس ناوەکەتی هیچ تر نابینم هیچ پیشان ناب
وڵی من شێرم کردو بە حساب تر نازانم ئەگەر لای تۆ کێشەکە بێت
ئێمە بینین
ئەو بزانە لای خۆت کوڕم شتێک هەیە جاریوا کات پەنجە بە شتێکی ترەکەوێت ڕەنگە لای بەرێت
شاتشمەوە هەر چاک نابێ بەس ئەگەر جۆ لێ بگرم مەژینە هیچ نابینم
سەیرە وەڵا
ڕفلێت تێکەرەوە لێ بەنامەکە داخەرەوەرەوە
ڕاوی بەرنامەکەدا بخێت و بێتەوە ڕەنگە باشتر بێ باسی تر من وڵا شەی یەکەم ینی هیچ کێشەیەک لە برادەرەکانی
کەم دام چاکە بێت
باشە زۆر باشە Now, from those classification, I will choose compounds. This is what you have studied, some of it you have studied in 11th grade. Compounds can be classified into two parts, two types, or let's say. Ionic compounds, covalent compounds. Covalent compounds also can be called as molecular compounds. Ionic compounds. Let's start with the ionic compounds. Ionic compounds are compounds which are formed from metals and a non-metal, a metal and a non-metal. Or I can say it's composed of a cation with an anion. In order to know ionic compounds, to recognize ionic compounds, what do we have to learn? What do we have to review? You had in 11th grade, you had two tables. Table in page 9 and page 14. I will try to upload those pages for you again. I will put it inside our folder in order to find the documents of chemistry. Go to your folder, chemistry folder, inside the Microsoft Teams. Then open files. When you click on chemistry, on top there is a tab called files. Open the files and you can see all the files, all the documents that I have uploaded. I have uploaded the booklet until now, and I will upload those tables as well for you so that you can memorize it again. See, you have, to me, you have already memorized these two tables because they are very, very important. Until the end of this, what do you call it? This book, most of the times I will tell you that have you memorized the table? If not, it's going to be a problem because there are a lot of compounds that you have to recognize them. And how do you recognize them? You have to know that table, those tables, let's say. All right. So that's how we form ionic compounds. From a cation, monatomic table, we had the monatomic ions and polyatomic ions. So a cation from those two tables and with another anion from those two tables will form ionic compounds. All right. An example of ionic compounds are the salts. There was a definition of salts in 11th grade. Don't worry. In chapter 3, we will define salts again. What are the salts? Which type of compound we call them salts, which is a type of ionic compound. And also, at the same time, we have strong bases, which also we are going to study in chapter 3. But as an example, so that you have a map in your mind, when we study chapter 3, you can come back to this map and you know what you are studying, at which point you are studying, all right? Now let's get to covalent compounds. Covalent compounds, which are also called molecular compounds, are formed from a nonmetal with a nonmetal, sometimes more than two nonmetals. For example, sugar, H2O, they're all covalent compounds. But we divide them into three parts. Actually, they can be divided into two parts, but so that it can be easier for you to understand, I have made the third classification. Covalent compounds can be polar and can be nonpolar. But there are some other compounds, we can say they have low polarity or intermediate polarity. They are polar, but they are very low polar. They are very low polar. which in this chapter we are going to use them in a certain subject. But polars, all the acids, chapter 3, weak bases, also chapter 3, we are going to study them, and H2O. These are all polars. What about nonpolars? Nonpolars, compounds with carbon and hydrogen, any compound. We don't care the amount of carbon and hydrogen. For example, here methane is CH4. It's composed of carbon and hydrogen, then it's a nonpolar. C2H6, nonpolar. C4H10, nonpolar. Please write this down as well. Amash bilirsin. Carbon also with halogen is also, if they make a compound carbon and hydrogen, they become a nonpolar. What are the halogen? Fluorine, bromine, and iodine. What about these? Babia.
Teacher,
Yes.
I have a question.
Yeah, sure.
Are the elements or molecules connected with van der Waals forces or hydrogen bonding, are they considered as distinct
Please,
compounds, or
please
are they
don't-
part of covalent compounds?
No. Please don't mix that. I'm going to talk about those attractions as well. Until now, we have two bonds only. Hydrogen bond, van der Waals, London dispersion forces are different from covalent bond, all right? I'm going to explain that in the next lessons, the next subject. Those are two different things. For here, we only have ionic bond and covalent bond, all right? Those are different things. They are not connected with compounds. You got it? All right.
So they are not considered as compounds.
No. They are not considered as compound. For compounds to form, we only need ionic bonds and covalent bonds. All right?
Okay, thanks.
You're welcome. All right. One more thing. These series that I have written here, Cl2, Br2, I2, F2, H2, are actually elements, not compounds. But why I have written them here? Because they are all nonpolars. They have nonpolar covalent bonds. All the elements here, they have nonpolar covalent bonds. But they are not compounds. They are elements, actually. They are here. They are not compounds. They are only elements. But for compounds, anything with carbon and hydrogen is nonpolar compound. Carbon and halogen also is nonpolar. What is left? What is left is compounds with, if the compound has carbon, hydrogen, and oxygen, they are considered as intermediate polarity or they have a low polarity. Or carbon, hydrogen, and nitrogen, they also have a low polarity. Polarity anash nesma. So this is a good classification. Covalent compounds can be classified into polars and nonpolars. All right. Any questions? All right. If not, I'm gonna.
يعني يكي كان بقول لك كربون لقل يكي كان أبي أوكاتا أبي بولاريتي كم يبي لو أبي كان شون بس.
لا يعني كربون وهيدروجين واكسجين هسي كان بيكو together. All of these three are together. يعني كربون هيدروجين نيتروجين ياخذ كربون هيدروجين نيتروجين together ليه compound بقول من هسه الشكل ها. If you look at sugar, it's carbon, hydrogen, and oxygen, so it's the low polarity.
بلا دس.
ماشي يعني.
دس كان.
سهل خوش به. Now let's start with 12th grade subjects. What are mixtures? We said two pure substances mixed together, we call them mixtures. Soil is a mixture. For example, if you grab some soil in your hand and you look at them, it contains a lot of different types of particles. It contains rocks, pebbles, sand, clay, decomposed animal, decomposed plant matter, and many more things. That's why soil is a heterogeneous mixture. But because it's a mixture, but it contains a lot of different stuff. If I take samples of soil from one place to another, they are different. That's why they are heterogeneous mixtures. What else is a mixture? Milk. Milk is also a mixture. It's composed of what? Fats. Please highlight or distinguish these from each other. Put numbers or highlight them, anything that you want, or underline it. Milk is composed of fats, 1, 2, proteins, 3, milk sugar, 4, water. So milk is composed of those 4 things. The fat, the lipid droplet in milk has a measure of 1 to 10 micrometers. What is a micrometer? 1 micrometer equals to 10 to the power of -6 meters. -6 meters. So they are from 1 to 10 micrometers. What about the protein of milk? Casein. It's called casein. They are about 0.2 micrometers. 0.2, so it's smaller than 1 micrometer. So the protein is smaller than the fat. Milk and soil are examples of heterogeneous mixture. Both of them are heterogeneous mixture. Why? Because the composition is not uniform. A student asked me in one of the classes, teacher, we see milk as a homogeneous mixture. Every part of it looks similar. Yes, to our eyes, we see milk as a homogeneous mixture. But actually, if we take it to the lab and separate them or take samples from this milk, we can see that the amount of fats, especially the fats, is different from the another amount of fat in another sample. So there are different amounts of fat in a milk throughout the milk itself, throughout the mixture. Maybe some fat has deposited or precipitated in the bottom. Most of the fat might be in the bottom. Some less must be on top, or like in different ways. That's why they are heterogeneous mixture. Another example of heterogeneous mixture is granite, which is a type of rock, I think. It's also a heterogeneous mixture. But salt and water, or dissolving salt in water, or maybe sugar in water, will form a homogeneous mixture. They will form a mixture which cannot be distinguished, which have the same property throughout the mixture, from the bottom to the top. For example, if you dissolve some amount of sugar, but if you dissolve it very well and you don't put a lot of sugar inside your tea or your water, when you drink the water, when you drink the tea, and it has a certain amount of sugar, the taste of the tea from the top to the bottom is actually the same. All right? Why? Because the sugar or the salt has dissolved entirely inside the water.
May I have a question, sir?
Yeah, sure. Yeah.
When sometimes when we put salt or sugars very much,
Yeah.
They collect in the bottom. Is it still considered as homogeneous?
We are going to explain that as well. That point we also have it in the subject, especially in section 2. All right. So you have to wait for the answer because it's a little bit confusing. I have to explain everything for you.
Okay.
Any more questions for this class? We are done here until now. I will wait for your questions. If not, we'll take 10 minutes rest and we'll come back after 10 minutes and we'll start types of mixture. Any more questions, please? All right, good. You can take 10 minutes rest. Right now it's 1:08. Please try to come back at 1:18. All right. You can leave that things, but I'm not gonna leave it. I'm just gonna keep it here. زۆر باشەوە دەست پێ بکەینەوە انشاءالله هەمووی هاتووەتە ژوورۆ. We talked about forms of mixture, the forms were homogeneous and heterogeneous. Now we talk about types of mixture. The first type of mixture, solutions. What do you mean by solution? When, for example, we dissolve sugar in water, that's called a solution. And the solute and the sugar must be capable of being dissolved. Capable of being dissolved. If you look at the definition of solution, what is a solution? It's a homogeneous mixture of two or more substances in a single phase. First, in 10th grade, this was the definition of homogeneous mixture. Homogeneous mixture is the one that has a uniform composition throughout. Dot. Period. Then, it is also called a solution. See? So, homogeneous mixture and solution are the same. So, the only type of homogeneous mixture is actually solution. The only type of homogeneous mixture is actually a solution. There is not any other type of mixture that is under a homogeneous mixture. So the only thing is actually a homogeneous mixture. The only thing is a homogeneous mixture. What else does it say? It says that it's two or more substances in a single phase. In a single phase, it means that when the solution is prepared, for example, when we dissolve a solute, the whole thing, when you dissolve sugar inside of water, the whole thing becomes one phase. They all become liquid, for example. That's what it means. Now, what are the components of solution? A solution must contain a solute and a solvent. And a solute and a solvent. The solute must be soluble inside that solvent. Not everything can become a solute. For example, if you put some sand in water, it will not dissolve. So it's not soluble. But sugar in water, it will dissolve. It is soluble. And it will disappear when it dissolves. If you look at this point here, the solid sugar is no longer visible. What does it mean? It has already dissolved inside the water. So solute is that substance that is being dissolved. But what about solvent? It is the medium used for dissolving. So the solvent is the medium. Bakurdi solute tuawaya, solute, solvent is tuenera. Let's look at the properties of solutions.
ما بس عفوا solvent تجيبه
tuener. Medium okay. Properties of solutions. We have some properties that we have to know. First property is the size of the particles. Size of solid particles is 0.01 to 1 nanometer. This is nano. What is a nanometer? 1 nanometer is equal to 10 to the power of negative 9 meters. 10 to the power of negative 9 meters. So if you want to divide 1 meter by 1 billion parts, you get a nanometer. And particles of solute after dissolution, after it has dissolved. So this is dissolved. After it is dissolved, the particles of the solute is 0.01 to 1 nanometer. That's the size. Since they are very small, they are homogeneous mixture. We said that before. Solutions are homogeneous mixtures. And the particles are very, very small. Can these particles be separated by filtration? No. What do you mean by filtration? We have a filter paper in a chemistry lab or biology lab mostly. It's like a piece of fabric. If you want to filtrate something, For example, something contains big particles. You put it inside the filter, and the big particles remain inside the filter, and the liquid or the other parts will go through the filter. But in solution, nothing will be left in the filter. Everything will go through. That's where we know it's a solution. For example, tap water is a solution. If we put it inside a filter, can you see anything separated from the water? No. Everything with the water passes through. Even if you dissolve some sugar inside that water, even inside the tap water, and you filtrate it, everything will go through the filter, including the sugar with the water. So nothing can be separated if we filter a solution. Particles, what happens to the particles then? The particles are dissolved and interspersed throughout the solution. Dissolved and interspersed. What does interspersed mean? It means that it has spread out throughout the whole solution. For example, when you dissolve sugar inside the water, the sugar is dissolved and it has been spread out to the whole solution. If you drink from the top, you feel the sugar. Drink from the bottom, you feel the sugar. So it is entirely spread out. It's distributed throughout the solution. They don't scatter light. This part, I'm going to explain it when we have three types of solution. I'm going to explain scattering light when I explain all the three types of solution. So for now, we only have to know is that they don't scatter light. All right. Now we studied components, solid and solvent, and these are the properties. These are the size. These properties are very, very important. We have to compare them with the other types of mixtures as well when we study them afterwards. They cannot be separated by filtration. We cannot filter, we cannot distinguish, we cannot separate anything. And they are dissolved and interspersed. We use the word interspersed. Let's go to types of solution. So now, types of mixture, solution. First one, solution. Inside the solution, we have types of solutions. These types have been categorized according to what? According to the physical states of the solute and the solvent. The physical states, are they gas, liquid, or solid? At which temperature? Room temperature. What is room temperature? 25 Celsius. From now on, in the next lessons, in the other chapters, there are some points when we say room temperature, you have to directly think about 25 Celsius because it's like a standard temperature. Most of the things are measured at room temperature at 25 Celsius, which is like a medium temperature. It's like a temperate temperature. A moderate temperature, sorry. Let's look at the physical state of solute and solvent. So this is the solute state, this is the solvent state. The first one, gas in gas. Even when I was a student, sometimes, a lot of times when we hear solution, we think about water, we think about liquid, but solution doesn't have to be liquid all the time. It can be gas, it can be solid as well. Like this example, like this one, like this type, let's say. Gas in gas. A gas solute is dissolved inside a gas solvent, such as oxygen in nitrogen. Oxygen in nitrogen here means air. نبستي هواء. Then why it says oxygen in nitrogen? Why it doesn't say nitrogen in oxygen? We have to answer that one, we have to look at this note. First note. if the solute and the solvent both are the same phase, both of them are gases, then the one with the larger amount becomes the solvent. Again, if both of them are the same, gas and gas, solvent is gas, solute is gas, then which one becomes the solvent? How do we decide which one is the solvent, which one is the solute, and which one is the solvent? The one with the larger amount, larger mole, becomes the solvent. So in air, oxygen is only 21%. What about nitrogen? It's 78%. So which one is more? Which one has a higher amount in air? Amount. We are not talking about mass or molar mass. We are talking about amount. The amount of nitrogen is a lot more than the amount of oxygen. That's why the oxygen is dissolved in nitrogen, not the other way around. كواتا هر كاتك لبيني دوشتا كعين فيزيان هبو كمان زورتر بو بيبقى solvent. Between two things, every time the one that is more, that one becomes the solvent. That's why I cannot say nitrogen and oxygen. Yes, I can prepare a container by myself which contains more oxygen than nitrogen. Yes, at that point I can say nitrogen and oxygen. But in air, since it's a constant thing, it's oxygen and nitrogen. So air is a homogeneous mixture. It's a solution, air. If I take samples of air in my room, for example, in different places, and then test them, take samples and test them and see what are the amounts of oxygen and nitrogen, in every sample they will be the same because they are homogeneous mixture, or it's a solution. Air is a solution. So that was the first type of solution. Second, there is a type of solution which gas can be dissolved in liquid, such as carbon dioxide in water. This is an example of carbonated beverages or soda. Soda is an example of carbon dioxide in water. The soda that you drink, Pepsi, Fanta, anything, it is carbon dioxide in water. It's an example of gas in liquid. Gas لأنه أوكاد توين راو لأنه liquid كا لأنه أوتواتو ككربون دioxide. كتوي خوتو هزبا أو غاز وشتكا أكيد بس أو تواتو لأنه أوكا. Third one, liquid and liquid can be mixed. For example, alcohol and water. Again, here, most of the time water is more than alcohol. If they are the same, again, please pay attention. They have to be the same state in order to know that the one with the larger amount becomes the solvent. If alcohol is more than the water, then we have to say water in alcohol, not the other way around. But in here, it is assuming that the water is more than the alcohol. What if both of them are equal? So we have to look at this note, note number 2. If the same phase solute and solvent, if they are the same, the solute and the solvent, if they are the same, and they are mixed at a 50% distribution, so they're also equal, then solute and solvent can't be determined, such as alcohol and water. For example, if you mix alcohol and water and both of them are 50% and 50%, then there you go. You cannot say each one of them is solvent or the other one is solid. كاجا پنجا بپنجا دابش كريه تو ناتواني قرار ببلي كاما solute كاما solvent. بو هر او عين هلينا. هیچ قرار هیچ نين الين solute solvent دياري ناكل.
اما ناويشان نيم جوانا اسا حاولتي دوم ناويشني تايبت بخوي.
لا. يعني ناوي كتابتي نبلا اشتكيوها هر الكحول او تاكلتن تو. جراوي الكحول نحن حاولت جراوي الكحول بيوتر.
يعني بس ما هيج ناويشني ما يعني نتواني قرار بك كمان زيادة solvent.
لا أنا أبي خوي بأمان بيت والله. هنا حالتها أبي أو أمان تكو بيت والله ياخد حرف كلمة شي بكارينه ياخذ إن بكارينه كإني بكارينه تو أزاني كمان سوليت وكمان سولفنتا مثلا يا كوتي إن
بس
يعني الكحولك سوليتا وترك سولفنتا أجر صدفة بس الرقمي نكرتبه تو سيدي هنا كرت سير الشرح كعكي بوي أزاني باش هذا
باش ما صغير بلين فمتي بفمتي به أوقات نوكو إما هاتنا توانين بلين هلا أجر بشي سلميني هل إما أبي بلين هل كاسام صلب أنت هل صلت واعي
آفرین ڕێگە قسەیە تەواوە ئەتوانین بە هەردووکیان بڵێن هەردووکیان سۆلیتیشن و هەردووکیان سۆڵڤنتیشن زۆر تەواوە ئەو قسێ تەواوە نمون بەڵێن ئەگزامپڵی دوایەوە the next one is liquid in solid mercury you know is the only metal that is liquid when dissolved in silver and tin where is it used in dental amalgams? What is dental amalgam? The filling in your teeth. Not nowadays they use a white filling, but several years ago most of the fillings were like silverish or a little bit gray filling. The gray filling was this one, mercury in silver, and you may have heard that the gray filling is not good for your health because of the mercury actually, because it contains mercury. But here's the question. Some students might wonder, how can a liquid be dissolved in solid? So the silver and tin are solvent and solid. How can we dissolve this one? How can we dissolve the mercury, which is liquid, into this solid? By heating, by melting the silver and tin. When we melt the silver and tin, we mix the mercury, and when it cools down, then it becomes solid. You might say, then, sir, what is the thing? Why do we say it is solid when we mix them as liquid? Because when they go back to room temperature, because where do we look at them? At room temperature. And silver and tin at room temperature are solid. That's why we chose the solid. At this point, there is something that we have to talk about. Point 3, note 3. The final phase of the solution is the solvents. Or we can say the final phase of the solution is same as the solvents. What do we mean by this? We mean when we mix two things, the final state is the same as the solvent. When you dissolve sugar, for example, the fifth one, solid in liquid, like sugar in water, the sugar dissolves in water. But what do we see? What phase do we see? Liquid. And the liquid is a phase of the solvent or the solute. It's the phase of the solvent. Same thing. When we dissolve liquid in solid, like mercury in silver, when it cools down, when it becomes the solution, what is the final state? Solid, the same as the solvent. This one, when we dissolve gas in liquid, what do we drink? Do we drink gas or do we drink liquid? We drink liquid. The final state, the solution stays liquid. The solution stays or have the same phase as it would have as the solvent, or as the solvent would have. So this solution and solvent have the same phases. كتبون من اشتكى توينيتوا فيزي أخير اشتكى solutionك كت حاضر بوا أو فيزي كsolventك هيبوا. بون أجر بالكودين بينتوب أبى بالكود solventك بsolid به solutionك شبه بsolid. بخشي وازه. Last one, solid in solid. For example, two metals. Again, we melt the two metals, mix them, then they cool down and become solid again, like copper and nickel. We'll talk about more examples of solid in solid down below. All right. So the first one, if they have the same phase, the large one becomes solvent. If they are 50%, 50%, we cannot determine which one is solid, which one is solvent. Final phase is always the same phase as the solvents. Number 4, alloys. جان
خالصية وزور زور بس ليش يعني
باشا خالص ما بس تيلة شيء يعني بقولنا كتو سولوشنكت حاضر كت همان فيزي سولفنتكي هي بونمنا شكر لأوات ويني نوا الأخيرة فيزي أو سولوشنا شكر أوكا ببتشي هببلك
جابي أوكا
كاتي أوكا وكوي أوكا ورجع لها مش تكاين تري شوا ماشي يعني من
So,
Yeah.
can you say the final phase of the solution is the solvent's final phase?
Exactly. The same thing. Yes. You can also say that. All right. Number 4. Alloys are also solutions. So what are alloys? Alloys are mixtures of solid metals. Mixtures of solid metals. Sorry. 12C. So when we mix two metals together, we call them alloys. We call them alloys. And they are uniformly mixed because they become solutions. We have some types of alloys, 4 types of alloys. These names are very important. The names are very, very important. First, monel alloy, which is a specific name for an alloy which is composed of copper and nickel. When copper and nickel are mixed together to become a solution, they are called monel alloy. It's a specific name. It's a special name. Second, sterling silver. Sterling silver, like silver and copper. If we mix silver and copper, we call it sterling silver. Brass, zinc, and copper. So all these 3 contain copper, 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 copper. Copper with nickel, monel. Copper with silver, sterling silver. Copper with zinc, brass. This gold, I mean the gold that is used in jewelry gold. It's not pure gold. So gold, we can say gold alloy. What is gold alloy? Is mostly composed of gold and silver. So when we mix silver into gold, it becomes an alloy. It becomes gold alloy.
مامۆستا پرسیارێت لێمە بەستی چیەکە نووسراوە ئاڵوی are mixed in atomic levels.
ئەوەستا شەرحەکەم خاڵی حوتەمە ها گەسێکی خاڵی حوتەم ڕێک ئەو خاڵێ بەجیا نووسیمەتەوە بەوردی ئەو شەرحەکەم لەگەڵ ڕسمەکە باشە کوڕم. What is the importance of alloy? Like, why do we alloy things? For example, an alloy between gold, silver, and copper. In our chemistry book, in the English book, gold alloy contains silver and copper as well. But in the Kurdish book, it only says silver. That's why I have written silver, only silver in this point. And in the ministry exam question, if it asks, we can only say gold and silver. Because in the Kurdish book, it has deleted the copper. But in general, the correct one is actually containing copper as well. Copper is also included inside that alloy. All right. What is the importance of alloying? First, most of you must have heard, for example, if you ask your parents, why don't we use pure gold? They will directly tell you that pure gold is very brittle, it's very soft, it will break. And it's exactly like that. If you go to a channel, there's a YouTube channel, they compress with a hydraulic press, they compress a 1 kilo gold, pure gold. And it looks like a rubber. It looks like something, what do you call it? A mud. It can be easily compressed. All right. That's why gold is soft That's why we don't use gold, pure gold. We don't use pure gold as jewelry. The gold must be, some silver and copper must be added to the gold, and that depends on the carat. For example, we have 24 carat of gold is 100% of gold. But anything more than that is actually less carat, for example, 22, 21, and things like that, and below. What is the importance of this? To add strength and hardness. To add strength and hardness. If we add silver, silver is harder, it's more stronger than the gold. So when they mix together, the gold will keep the appearance. We use the gold for this appearance. Retaining its appearance means it keeps the appearance, the beauty of the thing, of the solution. But the silver and the copper gives them hardness or strength so that they cannot break easily. توی altun زۆر نەما. ئێمە کەپەر و سیلڤەری تێکین بۆی ڕق بە پتەو ببێ تحملی پچڕان بکە. For example, copper, I don't think you remember, copper in 10th grade, one of the properties of copper was it is used to make wires. Why? Because they resist tension. They cannot be broken easily. They are not broken easily. That's why copper or silver are added to the gold so that the gold becomes stronger. When they use as jewelry, they don't break easily. The last thing is corrosion resistance. Corrosion means gradually becoming smaller and gradually losing parts. بەکوردی خۆمان داخورانی پێوتێ ئەها پارچە پارچەی لێ ئەبێتەوە تۆستۆزە وردی لێ ئەبێتەوە ئەو کۆڕۆژن داخورێ لێ ئەبێتەوە تێکەچە شقڵی. But if you add silver, since it has become stronger, it will not corrode. The corrosion will be less, a lot less. These are the importance of alloying.
مامۆسای کەسێت
گیانی من.
باشە خۆ زێڕی 1 کیلۆگرامەکان ئەوانەی کە ساف زێڕن نەداخوێن و هیچیان ئەوەنەش یعنی ڕۆکان نرم نییە ئەوان بۆ ئاوە
بە جوانی هەڵ ئەگیرێت بۆیە داخۆناوە ئەگینا گۆڵدی قاڵب هەیە قاڵبەکان ڕاست لەبەری زۆر ئەستورە ڕەنگە تۆ هەستکە ڕقە بلفە ڕقە بەس ئەگەر بێنی بیکەشی بە شتێکە زۆر بێسرحەت پانە بێتەوە هی نەبێت ئەگەری هێ بشکێت داشە خوێت یعنی ئەو قاڵبەکانیش داخورێت بەتابەتی ئەگەر ئاگیان لێ نەبێت داخورێت
ینی بۆیە سلڤەر و ئەوەی تێکەکەن کۆپەریتەکەن بۆی دانەخورێت
زێڕە بازنگێک بێنن دروستی بکەن لە پێرگۆڵد ئاوای لەکەن یەکسەر ئەشکێ یعنی بە بەسیترین جوڵە ئەشکێت ئەو قاڵبە گەورەیە ئەوە کێتۆ تا حدێت تەحمولەکە بەڵام مەسەلەنی تر وانە بازنگ و زنجیرشتووە هەر بەکەڵک نایە بە ئایر بشوارکە یەکسەر شکێ بچڕێت
ینی بۆی ئەمانێتەکەم بۆی بەرگری زیاتر بێت و دانەخورێت
زیاتر بێت تاوان هەتاکو ئەوانی زیاتر بێ بە قوتر بێت بەڵام چیە مەسەلەن هەرزانتر بێ ئاڵتوونی کەمترە بێت ڕەنگە تۆز جوان نەبێت ئێستا مەسەلەن ئایرە 21 و ئایرە 18مان هەیە ئایرە 21 ئاڵتوونی زۆرتر لە چاو ئایرە 18 تێگەشتی بۆ شێوازە بێت سەر خۆش گیان بابێنە سەر now let's talk about gold alloy. Gold alloy 24 karat of gold, we said it's 100% pure gold, but it's not a solution. But these three are actually gold solutions. So they are alloys. Carat, 14 karat, 18 karat, 21 karat. And if you want to calculate the percentage amount of gold in each one of these three, this is what you're going to do. For example, 21 divided by 24 karat, 24 is the total, 21 is the karat that will multiply by 100 and you will get the percentage. For example, 21 karat of gold, let's see what percent of gold it contains. We'll say 21 divided by 24, it contains 87.5% gold. All right. والله بينوسن بخوتان بو تيجيشن باشترا. اتبون من عليا الرسمك مان هيا. If you write it, it's better. We have a figure there. ها عليا. سالش دوباره بتانو نسمع. This figure, it says 14 karat gold is an alloy of gold and silver and copper. As I said, in the Kurdish book, this copper has been deleted. In the Kurdish book, this copper has been deleted. But the important thing here is 14 carat of gold. What is 14 carat? How much gold does it contains? 14 divided by 24 multiplied by 100, you will get 58.3% gold. And the rest, the other 41%, 0.7%, the other one are silver and copper. The rest are silver and copper.
باش ما وصل برسالة
يعني من فرق.
أو تصيم بس اللي صقر ما لا شيء.
نا أوصي بس بوي بيكم بpercentage بوي أوصي ما مودرش.
يعني فرق ناقة هل كان زور.
چوارده دەبەشی 24 کە ئەکاتە چەندێک ئەکاتە 0.58 0.58 یعنی چی یعنی لە 158
دەست خۆش.
It's a mathematical thing. باش قڕم خاڵی حوتە مەڵێ چی ئەڵێ alloys are mixed at atomic level. It means that when they mix together they remain as atoms. They don't become molecules. They don't mix as molecules. They don't become ions. نأبن بإيون. نأبن بمولكول رك أتومك إخوان. This is pure gold. See, we only see gold atoms. This one is gold alloy. And if you look at the gold alloy, it contains silver and copper. This is gold. The atoms of the yellow atoms are gold. You can see the copper as well. It hasn't become something else. It hasn't become iron. It has not become a molecule. Silver, the same thing. So they are mixed right next to each other as atoms. So the atoms are mixed together. You may not see it directly with your bare eyes. If you zoom it inside, you can see all the atoms are right next to each other without becoming something else. None of them have changed. They all have stayed as atoms just the way they were. That's why it's called the alloys are mixed at atomic level. يعني أتوم بتنشتي أتومه. يعني أتوم كان تكلينا ويكتريبون. أما gold alloy. برسياري كم دانا ولا صار gold alloy. I have a question on gold alloy. A sample of 12 carat. All right. 12 carat divided by 24 times 100 equals to what? 12 دابشي 24 چنکه لسا چنکه
ما صار 50
لسا 50 زور جوانا كواتا in 12 carat of gold there is 50% of gold. What is the alloy? If the alloy is composed of only gold and silver, so if 50% is gold, what's the other 50%?
Silver.
Silver. Here's the question. Which one is the solvent?
ما صوقات خالي دويلات.
ما وصل gold كsolvent.
هردو كان solvent.
يكي قوتي ما وصل زاتريانز أو solvent. لا. Rek هردو كان. This is second point. Second note. If two things, see, gold is solid, silver is also solid. Since both of them are solids and they are both 50%, that's why, what do we say? Solute and solvent can't be determined. زور راسته. كات اگر هاتو هدوكي 50 بو 50 بو او كاتا solute solvent ما بودر ناكرت.
ما يعني اگر دو ماتيريال ستيتكان يكشد بي او كاتا هر الين هردوك يعني solute solvent
بس بشرتها 50% بها. اگر هیچ كان زورتر بي او اسمبون من اللي عارض شوارده ها التون لسا 58 لسا 41 كيتري مثلا سيلفر بابلين. بەڵام مادام ئاڵتون زۆرترە ئاڵتون بە solvent بەس لێرەیە ناتوانین وا بڵێن. Another question on the same. Yes.
What about another state of matters? For example, liquid, solid.
Depends.
How can we determine?
It depends on the substance. For example, sugar and water. Can you imagine water dissolving in sugar? No, right?
No.
So it's sugar dissolving in water. For example, the thing that we had before, this one. Dental amalgam. Silver cannot dissolve in mercury. Only mercury can dissolve in silver. All right? That's what it means. But for the same state, since they are mixed together, you have to talk about which one becomes solvent and which one becomes solid. One more thing, one more question. I'm going to tell you this one just orally. I haven't written this question. What if instead of only silver, I say also, we have copper, gold, silver, and copper. The gold is still 50%. But can I say that the silver is still 50%?
No, it's got to be 25.
لا چونکە کۆپەریتی لەگەڵا.
هذا جولد
At that point, which one is the solvent? لو كانت شيء بقى solvent.
جولد.
Exactly. If I write copper here with the silver, it means that 50% is gold. The other 50% may be 25% copper, 25% silver. Then at that point, the gold is again solvent. But if we don't have this one, it will become like this question. It will be just this one. All right? Very good. Let's get to the next question.
Sir,
Yes.
may I ask a question?
Yeah, sure.
Can you mix alloys?
Of course. It will become a new alloy.
Okay, so
As
what
long as you
happens
use
if
them,
50% gold mixes
depends
with a
on-
silver copper alloy?
It depends on your amount. Which amount is the most, then you will decide which one is the solvent. It's
Okay.
up to you. All right?
Okay.
This question is Ministry Exam question 2014 in the first term. It says carbon dioxide in water. This is from the table. Carbon dioxide in water is an example of what solution?
Gas and liquid. D.
Gas and liquid. So the answer is D. The next question. All right. Next question might be a little bit confusing for you. It says, which of the
Change.
It is, yes, chemical change. Because everything we do here, there's no reaction. Every mixture that we have prepared here in the solution, there's no reaction. So if there is no reaction, it's not a chemical change. They are all physical changes. That's why. Which one is not true?
C.
Chemical change. Solutions are not chemical changes. They are only physical changes. Yes, they are homogeneous. Yes, they are physical changes. And in a solution, solute and solvent has the same properties throughout. What does it mean? It means that if we look at the solution, from top to bottom, when they become one solution, they have the same properties. All right? Their properties don't change throughout the solution. Ministry Exam question 2018. See, it's from the table again. In amalgam, between it has deleted the tin. There is no tin here, only mercury and silver. Which of the following is correct?
C.
Let's say you have to know the table. Mercury is solute and it is liquid. Silver, solvent and it is solid. Then you will answer the question. Here's how you answer ministry exam questions. Try to eliminate some answers. A, the solute and solvent are the same phase. No, it's liquid and this one is solid, so this is not correct. It's an example of liquid and liquid. No, it's liquid in solid. So if these two are not correct, D is also not correct because it says all mentioned, so this is also not correct. What is left? The solute is liquid. Yes, the solute is liquid. Then the answer is C. Any questions? Very good. So we are done for today's lesson. I hope you all have understood the subject. Please go back and review it because every day if you review it, you will understand it better. It will remain in your brains a lot better, a lot more. And if you try to solve questions, even better.
That's all.
سر خوش به. Have a nice day, everyone. Enjoy the rest of your day. Pakistan.